All right. Snipping that first picture in here now. What is the length of segment PQ? PQ. Okay. So PQ is over here to the right. Do you see that? And if we know X, we can find the length of PQ. Um, we need X. Well, we don't have X, but we know that these other two sides are the same. Since they're the same, you can set RP equal to RQ. So instead of RP, for example, you can write 3x minus 0.4 equals x plus 1.4. Is it clear how I did that?
Yeah.
Okay, so then you can subtract x from both sides, and you get 2x minus 0.4 equals 1.4. You can add 0.4 to both sides. So you get 2x equals 1.8. Divide both sides by 2, so x equals 0.9. That's not the answer. That's not what they're looking for. They want you to take that x value. We know that x is 0.9, and they want you to put that into x plus 0.1. So you can see that PQ equals 0.9 plus 0.1, which is 1. Is that clear for you?
Yeah, I got it.
All right. 8 and 9 actually are related to this question. They're going to go fairly quickly here. It asks for the value of PR. So PR is this side up here. Well, we know x is 0.9 from the previous problem. So PR is 3x minus 0.4. It's 3 times 0.9 minus 0.4. 3 times 0.9 is 2.7 minus 0.4. So that equals 2.3. 9 asks for the other side. So 9 is asking for the last side of the triangle. It is asking for the side RQ. Get that where we can see it. So it's asking for RQ, which is x plus 1.4. We know that x is 0.9. So RQ is 0.9 plus 1.4, which is equal to 2.3. That shouldn't be too surprising because the previous answer is 2.3, and we know that both RP and RQ are the same. So once you found that value, you know that it must equal the other side there. Is that okay? Can I move on to 10 now?
Yeah.
Great. 10, 11, and 12 are really similar. So effectively, the instructions are find all sides of the triangle. So let me paste that question in here. It wants the length of ST, but in question 11, it wants SU, and then in question 12, it wants TU. So basically need to find all three sides of the triangle here. This time, all three sides are equal. So we actually can set any of the two sides equal to each other. It doesn't really matter. I'm going to suggest, I actually don't see anything straightforward here. Let's just set, because we're trying to find ST, let's just set ST equal to SU. ST is the 2n plus 3 3/4, and that equals 7n. Okay, so 7n here is fine. We're going to move this 2n over to the other side. We're going to subtract 2n, subtract 2n. 3 and 3/4 equals 5n. We're going to convert this over here from a mixed number to an improper fraction. It's 4 times 3 plus 3. That gives you 15 over 4 equals 5n. Again, stop me if you have any issues with this. Normally we would divide both sides by 5 to solve for n, but because we have a fraction on the left side, it's probably better to multiply by 1/5 on both sides. So on the right side, those 5's cancel and you're just left with n. On the left side, you get 15 over 20, which can be reduced. You can divide both 15 by 5 and 20 by 5 to get 3/4. So n is 3/4. So what I'm going to do now is I'm actually going to snip in the figure again, and we're going to find all three sides because it's once we have the value of n, I mean that's all that's needed here. So n is 3/4. Let's find st first because that's the first thing it asks for. So actually, let me just drag that down here. So we know that n is 3/4. It's the same for all of them. So st is 2n plus 3 and 3/4. 2 times 3/4 plus 3 and 3/4. Let's do this one where we convert this into a decimal, 3.75. So 2 times 3/4. Let's go 2 times 0.75. So this becomes 2 times 0.75. That's 1.5 plus 3.75. So that equals 5.25. Now let's go find STU. STU. So STU is 7n. And we know that n is 3/4. So it's 7 times 3/4. Okay. Uh, let's make it into a decimal. 7 times 0.75. When you do this, you will end up getting 5.25. Now, should we be surprised about that? And the answer is no, because these sides are all the same. So once you find one side, you know all the other sides. So ST equals SU equals TU, and they all equal 5 point, what did I say, 5.25. So the question 11 is question 10, question 11, and question 12. They all refer to the same picture. They're all this 5.25 value. I hope that was clear.
Yeah.
Great. The fractions can be a little dicey. They can be difficult. You can use a calculator if you need to. So we'll move on here to 13. Min works in the kitchen of a catering company. Okay, great. Today her job is to cut a whole pita bread into small triangles. Min uses a cutting machine, so every pita triangle comes out the same. The figure shows an example. Min has been told to cut 3 pita triangles for every guest. There will be 250 guests. Okay, so 3 pitas for every guest. There's 750 guests. 3 times 250 is 750 pita triangles. Okay. If the pita bread she uses comes in squares with 20 centimeter sides, and she doesn't want to waste any bread, so basically they're saying like it comes in 20-meter sides like this, so it's like that's 20, that's 20. How many squares of whole pita bread will Min have to cut up? Wow. They just really made they really made this one kind of complicated. Okay. The so this is 20 by 20. So this triangle up here though, you can take this triangle down here and you can fit it up here. So all of a sudden you have this side and a rectangle. So your rectangle, it's going to have different dimensions. It's going to have two. It's going to be half of this 4 by 5.7. So the problem here is that you like I don't really understand why they're asking you to do this, but like if let's just say that's a pita, well, you can cut another one like this, and then another one like this, another one like that, and so on. Do you agree with that? Do you see that?
Yeah.
Um, the thing is though is that okay, so that's four, and so on. Well, you can get you can get five of those in a let me draw another one. So that's four. So we're up to 12, and then we got one more there, and we got one more. So that's another four. Let me scroll down here, and then you get another one of those, and there's your four. So you can get. Let me see if I can get this in here. You can get one, two, three, four, five of those. Okay, and then when you go out this other way, you basically have to repeat. But this goes out 5.7. So you can't quite get four in there. It looks like you can get three, row one, or you can get one here, you can get a second here and a third here, because this is going to go out another 5.7, and then it's going to go out another 5.7. So that gets you up to whatever 5.7 times 3 is 17.1 inches. So you're going to have a bunch of leftover. Because the way this reads is she doesn't want to waste any bread. Um, so I don't know if this is clear or not, but there's one, two, three, four, five, six, seven, eight, nine of these times three. So you get 27 triangle pitas in a 20 by 20 square. Because you get nine going this way, and then you get nine more there. They need 750. So you take 750, you divide it by 27, and then you round up because you're going to have an extra one. 750 divided by 27 is 27.77. So it looks like you need 28 of these 20 by 20 squares. There is another way to do it, which is if you assume this sort of rectangular shape, but I don't know if that's what they wanted or intended. So I guess if I were telling you an answer, I would tell you 28 for that. Um, so if any of that wasn't clear, I can definitely go through that again if needed.
No, I get it.
Okay. Um, that was everything in that email that I saw. Do you want to send me some more things for us to work on?
Oh yeah.
Okay,
Thank you so
I'll
much.
stand by. I'm going to pause for 30 seconds, but I'll wait for something to come in through email.
Sure.
All right, I'm back.
Might take a while. All right, I sent it.
Okay, I will look for it. Is this more geometry homework or something else?
Yeah, it's more triangles.
Okay, great. All right. What's the online program that you're doing? If you don't mind telling me.
The what?
Are you doing an online school or online program?
Yeah, it's just normal school, but it's all online.
Okay. All right. So, because I haven't seen this way of displaying the work before, so that's why I'm a little bit curious. Okay. So, question one here. This is an area in north central North Carolina is known as the Research Triangle. That's true. Okay. A lot of information we don't need. From Chapel Hill, the angle Durham and Raleigh, between Durham and Raleigh, the angle from Chapel Hill, the angle between Durham and Raleigh measures 54.8 degrees. From Raleigh, the angle between Chapel Hill. Okay. So it took me a while to read this correctly, but this is 24.1. From Chapel Hill, the angle between Durham and Raleigh is 54.8. So this is 54.8. So they're asking you to find this other angle right here. So you know that the sum of the angles, x plus 54.8 plus 24.1 equals 180. So we're just solving for x. We're just going to take 180 and we're going to subtract 54.8 and we're going to subtract 24.1 from that. If you have a calculator handy, I'd encourage you to try it. I will post the result here, but let me get to where I can enter those numbers into my calculator. So x is 101.1. All right, let's look at question number 2. The acute angles of a right triangle are congruent. So let's draw a right triangle. Here's a right triangle. And because it's a right triangle, we know that this angle measure is 90 degrees. If the other two angles are congruent, we'll call them x and x. We can find their measure because x plus 90 has to equal 180. If you subtract 90 from both sides, 2x equals 90. Divide by 2, so x equals 45 degrees. So their measures are actually the same. It's 45 and 45 for that. Okay, let's see here. New question number 3. Number 3. Let's see if I can get space on the here for. All right. The measure of one acute right angle in a triangle is given. Find the measure of the other acute angle. So we'll just do the same thing. We'll draw the triangle here. This is 90 degrees. We'll say that this one is 44.9. Okay, so we'll call that x. So x plus 44.9 plus 90 equals 180. If you subtract both of those to the other side of the equation, you get minus 44.9 minus 90. And you end up getting that x is 45.1 degrees. All right, so we're up to 4. 4 is, I guess, a little bit more complicated because they're not giving you an actual angle measure. They're giving you something that almost looks like an equation. It's actually an expression. We're going to do the same thing that we did in the previous problem. We're just going to draw the triangle. It helps if you draw the right triangles the same every time. That way you're not surprised. So we're going to call this 90 minus z. Okay, and this is still 90, obviously. And I'm going to call the missing one, the other acute angle, I'm going to call that x. So again, here's what we know. We know that 90 minus z plus x plus 90 equals 180. Now this looks really weird and different, but if you keep in mind that you're just solving for x and understanding that x is going to contain z in it, you'll be okay here. So let's combine like terms. So the 90 and 90 are get together, so that's 180 minus z plus x equals 180. If you subtract 180 from both sides, you get minus z plus x equals 0. You might think, well, this doesn't look right, but if you add z to both sides, you end up getting x equals z. What that's telling you is that this angle right here is z. So the missing angle is z in this case. And remember that worked out. Like if this in a right triangle here, okay, if you pick an angle here, let's call this 30. Well, what is this one up here? Well, it's 90 minus 30. Let's say it was 60. Well, this is 90 minus 60. So if it's z, this is 90 minus z up here. So it does work. Sometimes seeing it with the numbers really helps for understanding. All right, let's look at number 5. And okay, so 5 is again kind of the same. It's actually giving you a numerical value though, so this one's probably a little more straightforward for your understanding. It's saying, hey, one of the acute angles in a right triangle is given. Great. So that's 90. That's 0.3 degrees. That's x. So we know that 0.3 plus x plus 90 has to equal 180 because all three angles have to add up to 180 degrees. X is, you find that by taking 180 and subtracting 90 and subtracting 0.3. So x equals, you can get a calculator if you need to, but it's 89.7 degrees, which is still acute because it's less than 90 degrees. Okay, we'll get to 6. Quite a few questions here. All right, well, we'll keep going here. 6, find the measure of angle B. Okay, gonna snip this in. We'll start working on it. Measure of angle B. Okay, so angle B is over here to the right. It's right over here. That's angle B. It's actually the same as angle A. So these two are the same. So if you know A, you know B, but we don't know A, well, maybe we can find this angle up here. Well, this angle up here, I'll call it X. It's X plus 120. They have to equal, that has to equal 180 because they're on a straight line. So when you solve for X, X is 60 degrees. So this right here is 60 degrees. All three angles in the triangle have to add up to 180. So let's just call this one, I don't know, Y, and we'll call this Y. We know that 60 plus Y has to equal 180. So in this case, you get 2Y equals 120, and you end up finding that Y equals 60. And you might think, well, all three angles are the same. Well, that's true. That means that all three sides are actually the same. Any questions on that? Maddox, are you still with me?
Yeah.
Okay.
No questions.
All right. I'm sorry. There's just not more interactivity to this. Just it is the way it is. This one is asking, oh, I need to scroll up. This one is asking for the measure of angle PRS. So P to R to S, P to R to S. So it's asking for this, it's actually asking for this angle right here, which is this 9x plus 2. The value of x we don't know. So if we knew x, we would be done. So one of the things that's going on here that may not be clear is there's this property. Like I'm going to call this x, I'm going to call this y, and this z. X is equal to y plus z. So this angle right here, this angle P to R to S equals the sum of this angle in here and this angle in here. So we can actually set up an equation to solve. We can set up the fact that 9x plus 2 equals the other two values. So 23 plus 5x minus 1. Give this one a shot to solve on your own, and let me know what you come up with for x.
I got 5.
All right, so if x equals 5, which is probably right, this is 47. Yeah, so x is 5. That works great. So now, what did it ask for? It asked for the measure of the angle. It didn't ask for x, it asked for the angle measure. So you have to take 9x plus 2, and you have to put 5 in. So it's 9 times 5 plus 2. So that's 47 degrees. All right, we can move on to question 8. 8. Okay. All right, this is an example of a problem where they don't give you the image, so it's really important that you're able to draw the image. It says in triangle LMN, the measure of an exterior angle at N measures 99 degrees. So I'll try to illustrate that. This is N, and the exterior angle at N is 99 degrees. That's what that means. Okay, the measure of angle L, so we have to put in the other, so let's go LMN. So LMN, measure of angle L is 1/3 x, and the measure of angle M is 2/3 x. So from the previous problem, this 99 equals 1/3 x plus 2/3 x. So go ahead and solve that for me, please. So in this case, 99 ends up equaling x, because 1/3 plus 2/3 is 3/3. 3/3 is really 1. So since x is 99, we can find whatever it's asking us for. It wants the measure of angle L, angle M, and then this other one. So this 1/3 x is 1/3 of 99, which is 33 degrees. This one is 2/3 of 99. That's 66 degrees. And this last one right in here, we go over this way. Whatever it is, it's 180 minus the other two. But because 99 and whatever this angle is fall in a straight line, I think it's easier to say 99 plus, I'll call it y, has to equal 180. These two have to add up to 180 degrees. And you can see that angle there is 81 degrees. So angle L is 33, angle M is 66, and this other one is 81 degrees. Any questions on that?
No.
All right. keep going here. So next question, up another image, question 9. Question 9, find the measure of angle E. So there has to be something in here that allows us to either set two things equal or that they add up to something. So what we have currently is that this angle is congruent to this angle. This angle right here is congruent to this angle by vertical angles. And then we're missing some stuff. So have you done any like angle, side, side, any of that?
No.
Okay. Well, that's no good. Well, so we're just going to set them equal. So you can always set things equal, even if you if you don't know any better. I mean, that's all we have here. So you end up solving x equals 8. Whoa. X equals 8. And they want the actual angle measure at E. So we know at E, it's 6x minus 4. So that's 6 times 8 minus 4. 48 minus 4. It ends up being 44 degrees.
I don't understand that.
You need more information, and it's not given. So we're kind of stuck with just saying, that's just the way it is. If you really want more information, I can provide that, but it has to do with proving triangles are congruent.
All right.
Sorry, I don't like that answer either, but there's not much else that I can say. Well, actually, there's slightly more. There's this proof of triangles that if one angle is equal to one angle and another angle is equal to another angle, then the third angle must be equal to the other third angle. So like you can pick any numbers you want. Like let's say that's 40 and 40 and that's 50 and 50. Well, then the other two angles have to be the same. And I realized that after looking at this question here, this new one, it is based on that principle. So like that this angle is congruent to this angle, and that this angle over here is congruent to this angle over here, which means that angle V, must be congruent to angle T, because the third angle must be the same if the first two are the same. So I want you to set 10n minus 2 equal to 10n, 9n plus 9, and see what you get for n. So I'm asking you to set 10n minus 2 equal to 9n plus 9.
I got 11.
Yeah, I get n equals 11. That's not what they want, though. They want the measure of angle t, so you got to put 11 back into one or the other. So t equals 10n minus 2, 10 times 11 minus 2. You'll end up getting 108 degrees. All right, so let's see here. We're up to 11. 11 does not have a picture, which means that we're going to have to draw a picture. There's kind of two types of geometry problems, those that have a picture and those that don't. And those that don't, you have to draw one. In triangle ABC and triangle DEF, measure of angle A. Okay, so what I do when I don't know what else to draw is I just draw a generic triangle, A, B, C, and then I draw the same generic triangle and I label it the same way, D, E, F, and then I try to go in and insert the information. So measure of angle A is congruent to angle D. Measure of angle B is congruent to measure of angle E. Since two of the three angles are congruent, the other angle must also be congruent. You're supposed to find the measure of angle F if an exterior angle at A measures 107 degrees. So that's what this is. This is 107 degrees. That's your exterior angle at A. Measure of angle B is, this one is 5x plus 2, and measure of angle C is 5x plus 5. So we're going to use this exterior angle property that says 107 has to equal 5x plus 2 plus 5x plus 5. I'd like you to try and solve that.
I got x equals 10.
I agree. So x is 10. We got to remember what it's asking you for. Like these are actually good questions in the sense that like they always ask you to do something else. They want you to find the measure of angle F. They want that. Well, you don't know anything about this triangle on the right other than it's the same as the triangle on the left. Which angle is the same as angle F?
C.
C. So if we know C, we know F. Well, C is 5x plus 5. So that's 5 times 10 plus 5. That's 55 degrees. All right, let's get through this last problem here, and we'll probably have to call it after this. So let's see here, 12. All right, question 12. The angle measure of a triangle, angle measures of a triangle on the ratio 3 to 4 to 3. One of the things that you don't know until someone tells you, which means there's not much that you could be doing, is that you can always put an x here. You could say 3x to 4x to 3x. And the reason that helps is because you can go here and you say, well, that's 3x, that's 4x, and that's 3x. So you can always take the ratio and just apply x's to it. What do these have to add up to? What do these angle measures have to add up to?
180.
180. 3x plus 4x plus 3x has to equal 180. So that's 10x equals 180. So x equals 18. Whoa, whoa, whoa. What the heck happened? Huh. Sorry about that. I don't know why that isn't there. 3x plus, oh, there it is. Something's going wonky here with my tablet. Okay, so x is 18. Is that what it wants? It wants the angle measures. So you have to put 18 back into each of these. So 4 times 18 is 72. 3 times 18 is 54. And 3 times 18 is also 54.
So did I just write that in like 54, comma, 54,
Yes.
comma?
Yes, exactly. All right. I'm not sure why my tablet here kind of is missing out on some numbers, but they'll come back. This would be a good place for us to stop. I'll send you a PDF of the notes and the screen recording pretty much within the next 30 minutes or less.
Okay.
Thanks so much for scheduling, Maddox, and always enjoy helping you, and let me know when I can help you again.
All right. Thank you too.
You're welcome. Bye now.
Bye.